our first lesson is on percents, proportions, and order of operations. So let's talk about a few concepts that you remember from pre-algebra. 27%, if we want to convert that to a decimal, all we have to do is think about moving the decimal point back 2 spaces or simply dividing by 100. So that's going to be 0.27. And if I wanted to change that to a fraction, it's 27/100ths, so I'd start by saying 27 over 100. And if I wasn't sure if that reduced at all, I could take it on my calculator and hit math enter enter and see if it reduces, but it turns out this one does not. That is the world's ugliest 27, so let's erase that. Try that again. 27. Alright, 73.8%. If I move the decimal point back 2 spaces, we get 0.738. And this time it's 738 1,000ths, so I'm going to go ahead and do 738 1,000ths. And now when I hit math enter enter on my calculator to reduce this fraction, we come up with 369 over 500. So both those divided by a factor of 2. My last example in this section has 6%. If I move this back 2 decimal places, we have 0.06. And then if I take that, that's 6/100ths, which I know reduces because they're both even. So you could either do it by hand or math enter enter on your calculator, and you're going to get 3 out of 50. Our next section on the notes is more of this. So 45%, I want you to change this to a fraction. So what I would first do is I would say 45% is really 45 out of 100. Now technically that is a fraction. Unfortunately it's not reduced. So if I hit math enter enter on my calculator, I can go ahead and get the answer of 9/20ths, which is what I'm looking for. 0.318, change it to a percent. Now this time, instead of moving it back 2 spaces, I'm going to move it to the right 2 spaces, which is the same thing as multiplying it by 100. So we end up with 31.8%. And then 4/14ths, change to a percent. I'm just going to go ahead and type that on my calculator. So if I do 4 out of 14, and it's going to be a decimal, and I know to change decimals to percents, I just multiply it by 100. On my calculator, it comes out to 28.6%. In the next section, we have this proportion formula that you might remember from Algebra 1. It says is over of equals percent over 100. Now I'll be honest, I'm kind of stuck in my ways. I usually put the percent over 100 first, and then set it equal to the is divided by the of. But it really doesn't matter, because proportions you can interchange the order. Another proportion that we're going to see a lot of in this section is percent over 100, same start, but then it's going to be part divided by total, or whole. So it's going to depend on the type of problem, but let's look. Sam had $25 and gave 25% of that to Jennifer. How much money did he give to Jennifer? Well, we can go ahead and use this part over whole proportion formula. 25% is what he's going to give to Jennifer. And $25 is all the money he has, so that's his total amount of money. So it's going to go on the bottom here. And we don't know what he gave Jennifer quite yet, so we're going to do this on our calculator. We're going to cross multiply, take 25 times 25, and then divide that by 100. And it turns out he gave Jennifer $6.25. All right, I received a check for $200. Of that amount, I gave my friend $60. What percent of the check did I give away? Now you could use either one of these proportion formulas. They both will work. Let's try the blue is over of formula just to see what that works, how that works. They don't tell you the percent, so it's x over 100. And we're going to read very carefully. It needs to go is divided by of. So it says, what percent of the check did I give away? I gave my friend $60. Well, the of is also known as the total, and that's the $200, so we're going to put that down here. I gave my friend $60. They want to know what percent that is, that's why it's up top. So we're going to go ahead and cross multiply. This time we're going to take this diagonal, multiply those together, and then divide it by 200. And turns out, let's see, 30%. All right, moving along. Percent change. The formula that you're given here is the amount of change divided by the original amount. Now I'm going to modify that formula a little bit, and I'm going to say we're going to take the difference usually in prices, divide by the original. That's exactly what's written here. My modification is going to be, we're going to multiply it by 100. All that's going to do is take our decimal and change it to a percentage for us. So I was earning $18 per hour. I got a $9 raise. What percent increase did I get? Well, I was earning $18, and when I get a $9 raise, now I'm making $27. I don't actually have to use the number 27 because I know the difference in my two earnings were $9. So that goes on top. The original earnings rate was $18. And if I go ahead and multiply that by 100, I end up with a 50% raise. That's a mighty fine raise. Moving on. Okay, direct variation is an idea where two variables either both increase or they both decrease. So they have the same sort of relationship with each other. So the more you buy, the more money you're going to spend. The faster you drive, the further you're going to travel. So let's look at this example. A stamping machine stamps 320 envelopes in 5 minutes. How long will it take for 480 envelopes to be stamped? So since I have more envelopes to stamp, I'm going to need to have more minutes to have that happen. So that's why we can use a direct relationship, also known as a direct proportion. So the way we have it set up right now is envelopes for the first scenario, and then minutes for that envelopes, divided by envelopes for the second scenario, divided by minutes for that second scenario. So 320 envelopes in 5 minutes, 480 envelopes, and we don't know how many minutes that's going to take. So we're going to go ahead and we're going to cross multiply this problem. And when you do that, 480 times 5 divided by 320, you get x equals 7.5 minutes. Now it's very unlikely the ACT would leave it as 7.5 minutes. They would very likely write it as 7 minutes and 30 seconds because they don't like to have fractions of time events, but you never know, so we've got to be able to do both. Many of you may have set this up a little differently. You may have set it up as 320 divided by 5 equals 480 over x. The good news about proportions is that would have worked too. There's several different setups that are going to work fine. Indirect variation. This is the kind of relationship where as one variable increases, the other variable will actually decrease. So we can't actually set up a direct proportion for this. So if I did it like the last problem, I'm going to end up, and I'm not even going to do it because I know it doesn't work, I'm going to end up saying that when I go 150 miles per hour, it takes me 4 hours. And if I speed up to 200 miles per hour, a proportion is going to give me a number larger than 4 hours. Now that doesn't make any sense at all because the faster this plane travels, the less amount of time it should take. So instead of setting up a proportion, I'm first going to start with my two clues that they gave me at the beginning. 150 miles per hour, 4 hours. So if I take 150 miles per hour and multiply it by the 4 hours, I end up with 600 miles. That is the distance of my trip, and no matter what I do to my plane speed, the distance is going to be the same. So now I'm going to take that distance, and I'm going to divide it this time by my new rate, the 200 miles per hour. And I'm going to end up with 3. And that's my answer. Now this was a multiple choice question. If you look further down, there's a bunch of answers. And turns out we could have eliminated several of those answers just because they didn't make any sense. Anything that was larger than 4 hours had to be crossed off because that was not logical. And then order of operations. You may have heard something like, please excuse my dear Aunt Sally, or many of you I know learned PEMDAS. And they stand for parentheses, exponents, multiply, divide, add, and subtract. And that's the order of operations. Now the good news is your calculator knows the order of operations. The bad news is sometimes you have to add extra parentheses to make it work. For instance, here in example number 1, if you just type it in exactly how it's written, this is being a vertical fraction, you're not going to get the right answer. You have to tell your calculator where the numerator ends and begins and where the denominator ends and begins. So you're going to have to add another set of parentheses right here and right here. So you're going to type it in like, and I can actually show you on my calculator. Whoops, maybe. No, I can't. It won't stay up. Well, anyways, you're going to type parenthesis. Hello. parenthesis. 3 plus 8 divided by 2 minus 5, close parenthesis, division sign, parenthesis, 3 plus 5. And you're going to get the correct answer, which is 0.25, or 1/4 if you turned it to a fraction. Now, if you feel it is faster or better for you to do that without a calculator and do it by hand, that's fine. But most people will find on the ACT your brain's not working the way it needs to be working, and sometimes using a calculator, if you know how to use it properly, is the better way to go. Now, example 2 is a horizontal problem, and there are no vertical components to a fraction. So you can just type it in exactly how it looks without adding any extra parentheses. So when you type it in exactly how it looks on your calculator, you're going to end up with the answer of 44. So go ahead and try that on your calculator, make sure you get a 44, and that concludes our lesson.